All right, let's have a little look at line and rotational symmetry, what it's all about. So here's firstly a few objects that are symmetrical, or sometimes maybe they're not. Here's another one. Another one. Perhaps not this one. And an octagon. That is this one symmetrical or not? Not sure. Have a think. Another one. Okay, so a shape has line symmetry if you can draw at least one line through it so that one part is exactly the same as the other part. This part over here is a reflection of that part, so they're symmetrical. If a shape can be folded in half so that one half is exactly on top of the other, then we say the shape has got line symmetry. The fold is called the axis of symmetry. And this shape has got a vertical axis of symmetry. There we go. Okay. Let's have a look at some of these. So we've got three shapes there. Let's have a look at if and where the axis of symmetry is. There we go. Yep. Very good. So each of those has one axis of symmetry. Next. What about these ones? Two axes of symmetry, so I can fold them two ways. How many lines of symmetry has a square got? What do you think? So look carefully at the square. How many lines or axes of symmetry do you think we've got in a square? There we go. Looks like there's four. What about this shape? How many lines of symmetry does this shape have? I'm going to go with one. Oh, I got it right. Excellent. What about this one? I'm thinking probably two for this one. Very good. Next one, this one, triangle, equilateral. I'm going to go with three. 1, 2, 3. There we go. Next, this one. Let's go. I'm going to go with two for this one. Very good. And that's the end of that one. Now, let's see if I can get the other. There it is. Rotational symmetry. Okay. Now, before we go any further, instead of a line or axis of symmetry, the rotational symmetry is all about a point of rotation. Now, the order of rotational symmetry is determined by how many times a shape fits onto itself during a 360-degree turn. So every shape has at least one degree. Let's have a look. The square. One, 2, 3, 4. So the square has order 4. A heart. What is that one? Just the one. Order 1. A rectangle. What do you think? Looks like 2. Hexagon. 6. Oops, go back. Answer. There we go. Order 6. Let's keep moving. That looks like a rhombus. 1, 2. Order 2. Very good. Next one. A circle divided into thirds. Rotational symmetry. So, looks like 3. Question for you, what about if the circle didn't have any dividing lines in there? What would be the order of rotational symmetry for a circle? This one is order 3. And we're done. Oh, now, what we're doing as far as work, I've taken bits from the textbook and put them in a Word document so we can put stuff on them. And so we're just doing some of these questions. So we don't have to copy shape, but we can mark the axis of symmetry by going to Insert, Shapes, and we can do that line there. And so we can draw the line where we think the axis of symmetry is. And then once you've got that one there, Control copy and paste, and move the next one to where you think it should go. And so that's how you answer the first one. I'll just delete those. There we go. Next one. Well, we found that each shape does have a rotational symmetry, even though it's just order of 1. If it does, state the order. So 1 at least, 2, 3, 4, 5, 6, whatever it is, and you can put your answer in the text box here. 1 for each shape. And then copy the letters. Well, I'll copy them for you. So the first group of letters is line symmetry. Draw the axis of symmetry using the insert and shape idea. And the last question is copy the letters you've done, and you have to say the order of rotational symmetry and mark their center. And that's it. Thank you.